Welcome to this Fireside chat. I'll be your host and presenter. My name is Stephen from GlobalDots. I'll say a little bit about who GlobalDots are once we've done a bit of an intro and what we're talking about. So today's chat is around open source software, and they're specifically talking around the state of the open source security report, which was put together by SNYK. So we have a representative from SNYK with us today. Would you like to introduce yourself, Alyssa?
Sure. Yeah. Hi, everybody. Alyssa Miller. I'm an application security advocate here at SNYK. And as Stephen mentioned, the State of Open Source Security Report, I authored that report earlier this year. So we're going to probably dive into a lot of the things that we found as we got into some of the research around that report. Just as a way of biography, former developer. I've been in the security space for 15 years, working in various roles from managing security programs to consulting to now operating as an application security advocate at SNYK, getting out in the community and really trying to talk about security concepts and how they fit in the open source and DevSecOps community.
That's awesome. And then also from our side, we have Shalom. Shalom, would you like to give a brief intro to yourself?
Yeah, sure. I'm Shalom Carmel. I'm today the CIO of GlobalDots, and I have a black past in security and all kinds of matters related to that. I will be in the background providing support to anyone who needs support in this call.
And Shalom's dog is also here to answer any other canine related questions that pop up. So we have a rough format for how we want this conversation to go. And we can just talk and wax lyrical for a long time about open source and some of the problems that will come up through this report. That's not actually how we want to run this particular webinar. We'd be a lot happier if all of those people in the attendees, if you want to put questions into the chat, it would be way more fun for us to talk with your questions and you would get more out of it, and all around just a better experience all around. So please, if you have any questions, start putting them in there. A tiny bit on GlobalDots. I won't give you a full horrible sales pitch about who we are and what we do, but essentially we are technology specialists, and we find all cool new vendors from around the world, ones that are coming up, ones that people don't have time to investigate themselves. We partner up with them and we bring them to you. And one such partner would be SNYK, which is how we came to this webinar today. So I can still see a few people joining in, which is great. But let's kick off with a little bit of a chat about the report. Alyssa, you are literally the best person to go through this thing. You put it together. I will say, if you haven't read this, we'll send you a link to it afterwards. It looks daunting because it's like a 50-page PDF. But I legit read it. I think it wasn't actually so hard to absorb the information in there, but just walk us through a little bit about the way you put it together and the findings that came out of that, or the top findings.
Sure. Yeah. So the State of Open Source Security Report is kind of our flagship project. We do it once a year. And it's made up of some research and some surveys. And so how we put it together really is beginning with the open source community and going out and gathering data from some of the major repositories, just to understand the open source ecosystem and how it's changed over the course of the year. We also do considerable data mining internally, using data that we've been able to gather and aggregate through scans that are run using the SNYK tool, and looking at as well our vulnerability database that's based off of both open source community as well as our own research. And then we also produced a survey, and we sent that survey out. We got literally hundreds and hundreds of responses to this survey, just digging a little deeper and getting more of that verbose story around how organizations are handling things like their use of open source and their DevSecOps pipelines and what some of their expectations are and things like that. So with all of that, we're able to pull that all together and really kind of just analyze some of the key aspects of the open source ecosystem, where it stands from a security posture and so forth. So findings wise, I mean, there were a lot of different interesting points that we can talk about. Some that go to the complexity of dealing with open source and DevSecOps. One of the most common, and indeed we've seen this trend year over year, is just this idea of open source dependencies and what those mean to the security posture of our software. So when you think about writing an application, especially in modern day ecosystems, think like your JavaScript ecosystems like Node, or your Java, where you're using Maven Central package managers and things like that. There's this idea that, okay, I'm going to include these dependencies from the open source community. I might pull in say a Spring framework, or there might be a specific package I want to add to my project that gives me some functionality. And so, of course, when you introduce those dependencies to your software, that means you're bringing in any security vulnerabilities that exist within those dependencies. Now, what's sometimes more concerning and a little more challenging when we're talking open source development is that each of those dependencies has their own dependencies. And each of those dependencies has their own dependencies. And so visualizing that whole dependency tree sometimes can be really complex. Where it really gets difficult is then trying to figure out what is the overall security posture of all of these dependencies. And so as we look at them across the scans that we run with SNYK, what we see is that over 70% of the vulnerabilities that we discover in software come from those indirect dependencies that people often don't have visibility into. In fact, if you look at Node, for instance, we found that over 86% of the vulnerabilities come from those indirect dependencies, not the ones that are easily found in a manifest file or something, right? They're the ones that you really have to go digging for. So that was kind of that's a trend we've seen, and it continues on, and it speaks to really the complexity as you delve into DevSecOps and open source development, what that means in terms of just security posture of your software.
It was a really interesting part of the report, actually. There were two main bits that really caught my attention, but to dovetail to what you were saying there about the indirect dependencies, it was something like more than 60% were struggling or didn't have any control method for the indirect dependencies. So that was 60%. And then of the different tranches of organizations, it was like 30% technology, 20% financial services, and about 10% government. So you're like, technology, financial services, and government, they are in the 60% mark, not looking at anything outside of stage one, which is, well, especially financial services. But yeah, I mean, the government doesn't surprise me. Those guys are like always the last to get on anything. But there's this idea, and I got introduced to it like some years ago. I would say like 4 years ago. I went to a thing in a very fancy hotel breakfast. I went there for the breakfast, actually. It was a really nice breakfast. It was in the Ritz in London. It was like a champagne breakfast, but there was a very high speaker, and he was talking about software hygiene. And he described it like food packaging labels, where it's like, if your food looks like this and all the ingredients come from here, you would want to know about it, which everybody does with food. But for some reason, we haven't quite got there with software. And this guy was banging the drum like 5 years ago. He went on to, I forget the guy's name, which is terrible for this webcast, but he went on to go and advise United Nations and NATO about software security and phone hacks and the Apple sourced software and all that kind of stuff. But really quite frightening that, we at a base level, people aren't really doing much at all. Which I guess kind of, leads to one of the first questions, which is, what's preventing these companies from from reacting to the threats of open source software? So like if I'm in an organization, I know there's open source threats. Why aren't I reacting?
Well, I think actually you just made an assumption that speaks to part of the issue. Honestly, I don't know that all organizations even fully understand it. A lot of the conversations that I have when I get out in the community is just explaining this concept that, look, yeah, you've got developers writing your software, but the reality of modern development is no matter how hard you try, you don't get rid of open source. I've heard it postulated from different people in security and even development spaces that, oh, we're going to outlaw the use of open source. It simply doesn't happen because there are so many things. I mean, let's think back to like Heartbleed and OpenSSL. Who's going to roll their own encryption package and not use OpenSSL? Nobody, if you're smart, because we all know, I mean, from a security perspective, I shouldn't say we all know, from a security perspective, every security practitioner is going to stand up and say right away, don't roll your own encryption, use what's already there. And so, this idea that, oh, we're going to eliminate open source completely, just, it still permeates out there. And I don't think people realize. One of the stories I like to share with people, and indeed, as SNYK, we share it a lot. You'll hear from probably anybody in our developer relations team, is this Java application that we looked at. Just one example Java app. It's 80 lines of code contained in 3 files. So it sounds tiny little app. And then you look at it, and it's okay. They've defined 7 dependencies. And then you walk that whole dependency tree, and it's, there's an additional 59 transient or indirect dependencies. And suddenly, before you know it, it's 730,000 lines of code. And so I think what happens here is, one, organizations just aren't even aware that goes on. 2, there's that challenge of visualization. And organizations just, they don't, because they don't understand the threat, they're not looking at tooling and things that gives them that capability. Tools like SNYK that are able to walk that full dependency tree and identify where there are vulnerabilities and then monitor that software going forward. So if new vulnerabilities do show up in those dependencies, you are able to know about them and do something about it. That's just, it's simply not happening. And I mean, you mentioned financial services. Of course, we expect them to be better at this because they're usually top of the food chain when it comes to security practices. But it permeates everywhere. In fact, real life example, we saw it in healthcare last year in the United States. The FDA, who is in charge of certifying healthcare devices, they released this advisory about an open source package that was used commonly in a lot of the software for these healthcare or sometimes implanted devices, but where the FDA normally, when they release an advisory like that, they'll identify the suspected products that have this problem. With this open source package, they couldn't even determine who had it. So you had all these manufacturers who are out there producing this firmware and this software for their medical devices that are being implanted in human beings, and they couldn't tell you what software was a part of their overall package. And
Wow.
so that's like an astounding example of the true implications of this.
It's a great story. I'm just trying to imagine what the consultation would be like if you were one of those people later on. Yeah, we need to pull you in. We put some stuff inside you. We don't know what it is. Oh, good. And the packaging of open source, actually, while you were talking, it reminded me, again, this was quite some time ago, but there were pieces of hardware that were installed into the New York Stock Exchange that were had a vulnerability for Heartbleed, and it was baked in to chips that couldn't flash the firmware on them, basically. So I mean, they've probably got around to replacing them all by now because it was some years ago, but they were actually out in the wild. People knew they were in the wild. It was in the New York Stock Exchange, the worst possible place it could be, and had a vulnerability that they couldn't patch because they used this piece of open source. frightening. And it segues nicely, actually. I wanted to bring this up. I think you actually brought it to me, so I'm bringing it back to you. But it was the COVID-19 tracking apps, which is like really, everyone loves a good Corona chat. Come on, let's be real. But some of the highlights from that, I mean, in fact, I'm tempted to paste the link in the chat now so people can even look at it for themselves. But it was crazy statistics. Like 71% of apps had a high level vulnerability. 91% failed the cryptographic test. 85% of the apps were leaking data. The list goes on for all these horrible things. And I actually I wrote on a piece of paper with the date, and I put the UK track and trace app will get hacked or will leak data before the end of 2020, and like timestamped it and put it out there. And it's just going to happen. But can you talk a little bit around, quick app development, things like this happening in the wild and problems about that?
Sure. So this is where we kind of dive into that whole DevSecOps story, right? We've gotten to this environment where we're adopting the idea of a DevOps paradigm, and the DevOps culture is really meant to unite devs and ops and security to really grease the skids, or to push things through to production faster. And that's where this open source situation comes from, right? I mean, forget the encryption example for a minute, but even just simple functionality that our devs want to add to the software. Do I want to be paying an expensive engineer to sit there and develop functionality that is already available to them in an open source world? They can write 2 lines of code to include that new dependency and they're done. And now they've got that functionality. And so open source software enables that DevOps approach. But, again, the challenges are, from the security perspective, security isn't always well embedded in those pipelines. And it's our own fault. And I say our as in me being a security practitioner. When we think about security, we've always thought about security as gates, right? So we're going to have this phase of the development pipeline, and then we're going to have a gate. So you do your coding, then we're going to do some type of static analysis. Then we're going to move into testing. And when we get done with testing, well, then we're going to do a pen test or things like that. So at each stage, when you went from one phase to the next, we'd put some kind of gate there. And that gate threatened to push things backward in the pipeline. And so unfortunately, what happens is that breaks DevOps, because DevOps, the pipeline does not move backward. It keeps moving forward, especially if we're going for a CI/CD approach. It's that whole infinity loop that people have seen as well. If you want to think about it that way, it rolls one way. It doesn't go backward. And so what happens is, when we as security people try to put these gates in, we get rejected. We get shut out. We get circumvented. Those controls that we try to put in there, any security person out there understands the mantra of, if it comes down to security versus the business wins every single time. And that's as it should be, if we're not doing a good job of selling why security is a business value. And so we've got to get away from this idea of security being a gate, and instead, how can security actually accelerate the pipeline? How can I make the pipeline faster by integrating security into those phases? So how is security integrated when my devs are writing code? Do I have tooling or processes that integrate into their IDEs? Are we doing regular scans that occur at the point that they commit code to a repo? So now overnight that they can get results when they come back in the next day to continue work on whatever module it is they're working on. They've got information that's available to them. It's a quick feedback loop. It's stuff that they can view and they can fix it within the phase. Do I have threat modeling information that comes early on in my user story stage? And does that help me build my test cases when I get there and make that process faster? So there are ways to sell this, and there's ways to really demonstrate that security practices give you business value in the pipeline, But from a security perspective, we don't do a good job of that because that requires a different way of thinking that we haven't focused on in the past.
Yeah, and I like that it's actually a pretty common problem all around for security people, generally speaking. Like they are pretty much seen as the no man. You know, I've worked in before I joined the dark side of sales and this kind of world. When I was working as a solutions architect inside companies, I've seen people actively hide things from the security guy because they know that it's going to slow down the release. So like, you know, papering over these cracks and trying to hide things. But I think there's a part of the job which isn't really fully understood yet. And I used to work with a guy, Alan Kane was his name, but he was a great security guy because he really made it accessible for people to understand these security problems. I mean, one of the things that he did live with people inside the office when we had people in, without breaking any rules at all, he was able to find the IP addresses for black cabs that were running around London, and by not actually penetrating at all, but just using the open doors that were there, hack into a camera, and then be inside the back of a black taxi in London. And it was like jaws on the floor, and it was that kind of like wow factor that got people listening. And then he could spoon them some information, you know, change your passwords regularly, everyone, or something like, you know, while they're in that mode. But there's like it's quite amazing. And I think in some respects, the security people also have to step up their game in terms of how they present themselves. So I think of him as kind of a unique person that was able to do that. But a lot of the security guys, I don't know, it's you need some sort of charisma or something that doesn't seem to quite fit that role. You know, people who are deep in IT tech security don't tend to typically be dripping with charisma. Like, no offense to the guys out there, but it's, you know, the two are juxtaposed. But what gets me is that you have these massive things happening in the news, patches that could have been easily solved, and huge companies going under. There was like, you know, it leads to ransomware and all sorts of other things. I mean, the huge one that springs to mind was TravelX, which was, you know, a multi-million dollar, hundreds of $1 million company. It's just not around anymore. And that was largely put down to the fact they had this ransomware, which could have been fixed with a patched piece of whatever. And I'm sure there's still tons of them out there in the wild that are like that. They've got these patches. So in light of that, like, how can we better leverage the past experiences that have happened to open source and get better practices moving forward?
So the good news is I think some of that is happening. You know, one of the things we looked at in the State of Open Source Security report was we looked at what were the most common vulnerabilities that were being reported. So remember, I said we've got this massive vulnerability database, which is fed from the CVE database and vice versa. When we discover vulnerabilities, we are a CVE numbering authority, so we log vulnerabilities to CVE as well, and we aggregate a lot of data from a lot of tools into this vulnerability database. And so what we analyzed was what types of vulnerabilities are discovered, just as, you know, this vulnerability exists in package Y, versus how many projects actually get impacted because they have package X or package Y as a dependency. And it was really kind of interesting. So if you can picture this for the people on the call that can't see this, it's a scatter plot where I've got on the x-axis, I've got my number of projects. On the y-axis, I've got the frequency that a type of vulnerability is reported. So what I was looking for when we created this graph was that I'd have something in the far upper right quadrant, right? Like that thing that is very common and it impacts lots of projects. Well, what happened was that upper right quadrant is empty. And this was kind of surprising. Like, okay, so wait a minute. So I look at this, and what's the highest as far as the y-axis? What do we see the most of? Cross-site scripting. Cross-site scripting more than anything else. We tons of cross-site scripting reports. We see them all over the place. They come in all the time. But they affect a relatively small number of projects. On the flip side, vulnerabilities that aren't very well understood, necessarily because we don't see as many of them. They're not as talked about in the industry, had the biggest impact. The most impact on projects came from prototype pollution, which I'm willing to bet, as I say that term, there's probably a lot of people out there that don't even understand what prototype pollution is. I don't know that I want to go into a whole explanation here. Just understand that it's a particularly impactful attack on the repository itself. Certainly, I can get a link for folks to a blog that describes it way better than I possibly could. But so in any event, what this indicates is, to me anyway, as we started to dig into this, is that those more popular packages, the ones that have been around for a while, that get used in a lot of projects, they've kind of refined over time, and they're eliminating what I hate to call it low-hanging fruit, but the well-understood vulnerabilities. On the flip side, those novel ones that are new, those are the ones that still slip through. And so even the most mature packages get hit with those, and that tends to affect large numbers of projects. I look at that prototype pollution. We had only 14 reports in 2019, but it impacted over 120,000 projects. So that gives you some idea of just, how widespread that can happen. We go out to GitHub and just look at some of these packages, or go to NPM and look at how many downloads a day some of these packages have. We're talking millions and millions and millions of projects that one vulnerability can impact when it's found in that particular library. So, so there's good news in that we do see that continually improving over time. We do see packages. So it really comes down to now, how do you assess the health of the packages that you use? And so organizations, that's probably one of the key things that I think people are still struggling with, is this idea of package health, and how do we measure it? Do I look at packages that are active? They see active development. Well, that doesn't necessarily mean their security posture is good. Obviously, if it's a package that's been, dormant for 2 years, there might be some issues. You probably don't want to go with that package, but that's not the only metric we can use. So why don't we couple that with looking at, okay, just how many issues? How fast does the maintainer respond to issues? Are they actively merging pull requests? How many maintainers are active on the project? Things like all of these. And so what you start to see is that you need kind of this comprehensive metrics model. You can't just look at one aspect of a package in order to, how many stars it has. Okay. That's no measure at all, right? We have to look at these things comprehensively. Number of stars can be helpful. It tells us how popular it is. And if a lot of people are using it, we know that it probably sees a little more attention. But, I think as organizations kind of look at open source, how can we enable devs to understand the health of the packages that they're pulling in? And then is there tooling that can sit in the IDE and help them truly understand, hey, you just added this package. It has 15 critical vulnerabilities. Maybe you want to rethink that.
Yeah, I like that a lot. And it definitely segues into one of the bits I really wanted to talk about, which was the state of the actual packages now. So these containers out in the wild, and it was by far and away, when I read the report, it was the thing that sprung out of me. And even as somebody who works in the industry and who's, absorbing things like this quite frequently, I was still pretty shocked to see it. And it was the vulnerabilities that are in official containers now, like available. So it's something of a myth, I think, within IT organizations. And well, I say that from my point of view, because it's something I thought, up until not so long ago. And I think probably there is this, some sort of belief that if it's a latest package pulled straight from the repository, it must be fine, especially if it's a well-maintained one. And kind of the truth behind that is no, because it's open source and it's all free. And the guys who look after it do it in their spare time. So there's not loads of impetus to fix things that are sitting in there. You know, nobody's cracking the whip because nobody's to blame with open source. You know, you can't drag the CEO of open source in front of people and go, your package is full of this. It's nobody. You know, it's just a faceless bunch of nerds somewhere on the internet, which is brilliant, but it leads to this weird situation. So yeah, I'm not going to share the chart, but we will link to your report afterwards. But the one that was amazing was official vulnerabilities right now inside packages, and there were 642 in Node and 83 in Nginx, and lots of people use Node and Nginx side by side. That's more than 700 vulnerabilities straight off the bat, and you like nobody would do it. Nobody would do it if they knew that. If you told it, pull the latest 2 packages for Node and Nginx, and then I just said, you do know there's 700 vulnerabilities in there, don't you? Like nobody would package that. Like you'd be off your head. And yeah, I to talk around that a little bit. I mean, the community that supports them, what we can do to help them, what they can do to help themselves, and what the developer can do to not pull in 700 vulnerabilities.
So you said it, first of all, it's awareness, right? So I wish I should have, I kick myself every day for not screenshotting this blog. As I was researching this report, I came across this blog from somebody who had, it was like a weird Ask Abby thing where they would send it, he would get questions from people and he would answer them in his blog. And one of the questions was about building a secure container image. And you know, even in there, he made the assumption is, oh yeah, go to Docker Hub, grab the latest official image, and you should be good. No, as you mentioned, we looked at the top 10 most popular official images in Docker Hub, right? And people hear that term official image and they assume official means secure. No. As you mentioned, Node, we saw that there were 642 vulnerabilities. In fact, it's funny when you look at the chart, because the Node image in particular is so much of an outlier. We actually had to break the scale to fit it into the page. I
noticed that when I was looking at the report. You actually, you had to break the chart to fit it in. That's how bad it was. Yeah,
we're gonna go from 100 to 600. It's kind of like some of the COVID charts you look at lately. But you know, and so what happens too, unfortunately, is with that, everybody gets focused on the 642 and they miss the fact that all these lower bars are actually still really significant. You mentioned 83 in Nginx, 67 in MySQL, like, so again, it sounds all doomy and gloomy, but the reality is Docker is kind of on this now, right? I mean, Docker is a partner of ours. And we've worked with them, and now tools like SNYK are integrated. I mean, SNYK is integrated right there in Docker Hub. You can actually run a scan. But a lot of this is also just what's old is new again. There was belief. I won't say we all, because I think some of us were appropriately skeptical. But when containers started to arrive on the scene, they were touted as, oh, this was going to save the world. We're going to have all these compact, ephemeral infrastructure components that our software is going to run in, and then we're going to deconstruct them, and then they're going to go away, and that's going to take care of all the vulnerabilities. Well, yeah, that didn't really do anything, because what happens when you go to build a container? Well, it's the same thing as when you went to build the operating system. Nobody takes the time to sit down and figure out what libraries does my software actually need, and what can I get out of this package or out of this image, out of this operating system that's just going to potentially introduce vulnerabilities for stuff that doesn't even need to be there. And that Node package is a great example. So first of all, it runs on a vulnerable version of Debian, which isn't surprising given how Debian releases security updates. But when you really deconstruct it, so for those top 10, all I did was I grabbed the latest. So, Node dash latest, Postgres latest, whatever. And so with Node, you get this massive buster image, right? It's the big, beefy, you got every possible library. Well, one of those libraries it's got is ImageMagick. And I'm sorry to all the folks who told me on Twitter a couple of days ago when I was looking for help with some image processing to go grab ImageMagick. when you look at the 12 pages of CVEs for ImageMagick, you might want to rethink the use of that. So of course, ImageMagick introduces a ton of vulnerabilities to this node package. So 642 vulnerabilities, but what we found was if you, instead of grabbing node latest or node buster, if you grabbed node slim, 642 is reduced down to like 53. So, okay, wait a minute. This is what we were talking about years ago with, on-prem software and hardware. It was, minimize what you're installing. Don't install all the libraries you don't need. It's the same thing in containers. And so we haven't gotten over that hump yet. And I think, that's something that we're trying to get to. But so it's the same concept we've talked about for 2 decades of how do we harden servers. Well, now we're looking at how do we harden container images and the Kubernetes clusters that they're running in, right? I mean, it's the same story.
Yeah, I really like that. And that totally resonates with me because I'm old school and I was on the infrastructure side when that was happening, when it was like, guys, do we really need to have the full visual desktop experience installed on this web server that faces the internet, including a calculator and solitaire? I don't think that's necessary out there. But yeah, we're on the same thing, basically. We're now at the same thing where, and like a part of it probably boils down to time, I imagine. Everyone's under pressure. You've got to get the next code release out and blah, blah, blah. And then someone says, hey, do you want to investigate? Do you really need this whole node package? You've just made someone's eyes roll into the back of their head, but it's definitely food for thought. If you're sitting in that position. And on the same subject, actually, there was another article, and I'll post it in the chat, but it's around this idea that if the latest image is pulled, it must be great, basically, which is, flagrantly not true. And again, my jaw was a bit on the floor when I looked at some of these things. So it was against a national vulnerability database, and they scanned the top 100 or something like that, and how many days it took for them to act on a vulnerability that was found, basically, on a new vulnerability that was found. And there were some mega ones in there. GitLab, their average was 76 days, which was a really crazy one. Elasticsearch was 98 days. OpenStack was 130. And that's crazy to think people build their whole infrastructure on OpenStack. Ansible was 151 days. Logstash 173. And then MongoDB was 240 days. And you're like, MongoDB is everywhere. Like Mongo, it powers massive parts of the internet. Crazy. So again, you would think, and these aren't necessarily things that you wouldn't even think about some of those things. I mean, I doubt people really worry too much about MongoDB, but maybe they should start worrying a little bit more about that. But yeah, that sort of backs up this idea that, not only, because some of the open source things that doesn't have a face to them, it's just a bunch of guys trying to keep them updated. But for sure, there's somebody who works for MongoDB. These actually have paid employees. You could string someone up from MongoDB, and they still have them. And it's also very interesting. You talk about the old is the new as well. It's definitely, we're seeing a return to the oldest types of attack, or like a new take on the old types of attack. Particularly cross-site scripting is something quite interesting. And I think we have Fiona, who's one of the attendees, who's another partner of ours who works for Source Defense. So working on the other side of protecting JavaScript libraries. But again, we're seeing like Magecart, form jacking, these kind of attacks that are happening on people. And it's exactly the same thing, but it's on the opposite side. It's not the development side of the pipeline, but it's like the public facing / client side. So it's like kind of like history repeating itself, really. We're not really learning, are we? As a set of professionals, we seem to be a little bit stuck. So we know what you do, what SNYK do, and we've talked around a few things. So what would appear to be prevalent from your report was that a lot of people, most people really, aren't doing much or don't know, or certainly aren't doing much outside of the first level of dependency. So if someone's on the start of this security journey, what are some basic steps they can take? Easy steps, maybe free steps, things like that.
Sure. So, I mean, from my perspective, and anybody who knows me knows that this is one of my passions I talk about all the time. I think one of the easiest things that organizations can do, and when I say this, you're going to say, Alyssa, that's not easy, is threat modeling. Now, when I say threat modeling, a lot of people cringe, especially anybody that's done it before or is working in DevOps, because we think about this big, heavyweight process. We think about that book that Adam Shostak authored a number of years ago, and things like Stride and Pasta and Dread and TAPAC and all these things that frameworks and everything else we threw at threat modeling. It's this huge effort. So what I tell people is, take that back. We keep talking about pushing left. Let's really push left. How far left can you push? What is the farthest left you can push in the pipeline so that anything that's going to slow you down won't impact the actual speed of development? Well, it's your user story, right? I mean, you can't go any farther left in the pipeline than the user story. Everything in the pipeline starts when that user story lands on a backlog. And then that gets pulled into a sprint, and then that sprint, it gets developed and tested and deployed, and we cycle back through and we do it again. But then think about this in terms of how do we just get better, right? I mean, if you're talking about somebody who's starting on a security journey, you've got nothing today. To think that you're going to secure your entire environment in 6 months, a year, that's not a very realistic business case. So instead, how do we focus on just continuous improvement? And so instead of trying to threat model, say, an entire application, or an entire set of microservices, or whatever it is, just think in terms of the context of just that user story. And now, how do we put it into plain language? So instead of having a bunch of security people and devs write up a bunch of technical jargon about threats in this user story, have the people who are writing the user story write up the threats and use plain language, stuff that has context to the business. So now they write it as, instead of, oh, it's a threat of spoofing or tampering or repudiation, as we, the Stride categories. Instead, it's just, hey, this is a critical asset. We have critical assets here. It's this piece of user data, or it's this financial asset, or it's just our key business asset here is just the availability of this particular functionality and that sort of thing. Now, what are the threats? Well, the threat is it could get stolen. So we have a threat of theft, or, somebody could affect its availability. So there's that threat, that threat of interrupted business and things like that. So talk about threats in that sense, put that in your user story. Now, when your devs take that and they start to plan in their sprint, if you got architects who do design, or if the devs are just doing it in real time because it's more CI/CD, great. They can at least internalize it, conceptualize it in their head. And now, if they're really in a DevOps culture where they're working with security, hey, we can figure out those security controls, what they should look like. Now, I can code those. I can add those to my code, but it doesn't stop there because I've got that threat information. Remember, I mentioned before, threat information feeding your test cases. So now I know what controls I built, what threats they are supposed to prevent. I can test for those with specific use cases. And then post-deployment, I can use all of that information to build my monitoring and to monitor for incoming attacks and to monitor for those security issues. So one little thing you can do at the very early cycle feeds the rest of your pipeline. And this is where I talk about security demonstrating that value, because that makes the entire pipeline more efficient, more secure, and more mature. So, a very simple step. And then we can talk about tooling. Notice I didn't mention tooling at all in any of that. How often when we talk DevSecOps do we focus on tools?
Like all the time. It's only tools. We
forget DevOps is a culture. I mean, read you go back to 2008 when, Patrick Dubois kind of came up with this idea in the first place. He wasn't talking about how do we get technology that makes things do this. It was how do we unite these two groups of people into a culture where they work together and make this happen.
Yeah.
And then tools, process, everything else comes into that.
That's like a totally separate podcast or something all of its own. But yeah, the idea that you hire DevOps people always used to make me laugh. It's like, we need to hire DevOps. You need to hire a culture. That's interesting. Yeah, scratch. Yeah, and I like the idea of this English language thing. I was chuckling to myself because, you talked about all these different categories and it's like IT mumbo jumbo, but maybe just do something that's even funny, like have a brown pant rating, like, slightly brown to completely covered in poo. We're in a poo situation, or, pants down situation. This is a level 5. We are open to the world situation, something that non-techie people can really get a hold of, something that makes sense to your company rather than just sort of IT jargon. So we've got a question from Eli, which actually I quite like. How can businesses count on the open source community to fix vulnerabilities in open source packages? And should the businesses dedicate some of their developer security talent to contribute back to the open source community?
So this is the fun question. I actually am super glad someone asked it, because this is the challenge when we think about it from an organizational perspective when we're using open source. And there's a couple things I think organizations need to focus on here. First and foremost is kind of what I mentioned before, just having a strategy for how you're going to manage package health. How do you know which packages are ones that are useful to you and are acceptable from a risk perspective to introduce into your environment? And how can you enable your developers to be able to understand that? So giving some definition to what package health means and just understand it from that perspective. So there are tools out there. You can look at how long it takes a particular maintainer to respond to issues and things that are reported. Great. The second part of that question is the challenging question for a lot of businesses. And that is, do I spend my developer resources fixing vulnerabilities that exist in open source packages? Now, there's a couple schools of thought here. On one side, sometimes that becomes a necessity, right? You may need to do that because if it's going to take 2 weeks for a maintainer to respond to you and to fix your security vulnerability, you might not want that vulnerability sitting there that long. So if you instead code a fix and submit it as a PR, now they can merge it and you've already fixed it for your code, and hopefully they merge it and that becomes a part of the code base. You've helped make that particular package safer, and over time you're helping make the whole ecosystem safer. The challenge comes in is that, of course, you are dedicating your resources to the open source world to some degree. And I think, unfortunately, that's how a lot of organizations look at it. And then they tend to believe that, that's a misuse of time and whatnot. But the reality is, think about what you saved in terms of time by using that package. The devs that didn't have to write all that code. So now if there's a vulnerability in it, just adopt it as if it were your own, fix the code, and submit it as a PR. You haven't really spent any time outside of your organization. That's all time that you would have had to spend and more had you written that yourself or had it been a vulnerability that occurred in your own software. So, there is that perspective. I've heard mentioned, well, what about liability? Well, again, it's the open source community. Nobody's liable for the vulnerabilities that occur. At least I'm not familiar with any legal case that's occurred where an open source maintainer was sued for the security of their software. That's, the nature of open source, the nature of the licensing that typically is included with open source packages kind of precludes that. So, from that perspective, I think it's okay. And then the last piece is really just where possible, and this is a little more community oriented, a little more ethereal, but look at how your organizations can actually help support the open source community as a whole. There's a lot of academic research being done on vulnerabilities in the open source community. A lot of the researchers we get vulnerability reports from are coming from universities where they have labs and they have graduate students who are just working on vulnerability research all day. So how can you as an organization support that and help keep those labs doing what they're doing? So I hope that touches on all the aspects of that question.
Yeah, that was a great insight. And, you know, people should just be giving some free time to this stuff anyway. You know, if you're endlessly taking just free stuff, surely at some point you think if you've got a spare sprint, you could dedicate it to these guys. I
mean, it's in your own best interest, right? Or if you want to look at it a different way, think about it like I don't know if I'm US centric when I say this, but we've got the little change trays at when you're at the register to check out at a store or something. If you need an extra penny or whatever, you take a penny and you give. Well, if you're always taking and you're never putting in there, if everybody did that, there wouldn't be any left.
Yeah, guess what? Yeah, guess what? There's also something quite interesting around people just paying for software generally, and I mean this across. I think now with the world of, so you got Kubernetes, and Kubernetes is an open source platform. So now the platform that holds these things is now the same one that Google uses, and you can have that for free. So it's good enough to power Google. Sure as hell, it can power anything else. So I think there's also a mindset around spending any money where it's like, this is open source and this is what powers us. We use open source containers. Like the idea of paying for anything around this sort of container world, Kubernetes, Docker, is kind of like, it gets a cold shoulder basically, which I can tell you working in sales makes life pretty hard to try and convince anybody to buy anything when they think they should just have it for free. But there's an argument for paying people, to have things paid. You wouldn't get a tool like SNYK if people weren't paying for it. There are problems with this open community. We've only got a little bit of time left. There's one last thing I'd like to talk about and how it relates to you and the ecosystem going forward, which was OpenSSF. So this is the Microsoft, Google, IBM merging together to now tackle the open source security bugs. And what difference does it make that these three big heads are now in the game? Are they going to create the vaccine for the open source virus? Talk around that for us.
Yeah, I mean, it's one of those things that goes back to, again, what I was saying before of commercial organizations really investing in open source community, right? I mean, I don't think bad things are going to come of this. Let me put it that way. Do I think it's going to be the end all be all answer that's going to make everything better? It'll make things better. I don't think it's going to solve all the problems. You're still going to run into the challenges of kind of like you were just saying. You've got open source maintainers who, they're not making a living doing this. This is just stuff they do on the side. I was just talking with a colleague of mine the other day on Twitter, and she was lamenting the abuse she takes sometimes in public. She will be out in public and people will recognize her and come up to her as she's grocery shopping or whatever and yell at her because there's some bug or vulnerability they found in her package that hasn't been fixed yet.
Too good. Hey, I took your software for free, which you did in your spare time. How dare you? Yeah.
Right. I mean, it's like so we still have to understand that there's going to be maintainers like that. Now, I mean, with, what OSSF does for us is it does formalize more of, I guess, that research and people actively trying to work towards fixing vulnerabilities. So how are we going to find them? How are we going to go about fixing them? How are we going to make sure that maintainers are more aware of security practices? I do see that coming from it. But yeah, I don't think there's one end all be all answer that's just going to fix it all. And security, we tend to think about things that way. how are we going to never have to deal with this again? Well, come on. We're always going to be thinking about security. We have to be. And so I think the more that we can do to actively have the commercial world engaged in helping secure open source, since the commercial world is going to be using open source whether they like it or not, that lends some significant ability to really improving that overall landscape. So I think it's a good thing. I think it's a move in the right direction. I don't necessarily see it as like an immediately earth-shattering shift in the open source community, but it will over time. It will definitely pay dividends and make things better, as long as, again, the members of that foundation remain engaged and continue to support it going forward.
Great. I couldn't agree more, basically, and actually having some real money behind it. I mean, if anyone's got the pockets to have a go at this, it's definitely that group of organizations. I mean, and the ones who've probably made the most money out of it. I mean, the whole of AWS runs on open source. It's like, come on, give something back. Okay, I think we're at the top of the hour, really. It's been great talking to you. If anybody wants to reach out to us, please do. We'll send a copy of the webinar out and all that other stuff that we'll have to do. That's all lovely. Big thanks to SNYK and specifically, obviously, you, Alyssa. Cool company and non-related to tech. I don't know how they've done it, but there is an awful high number of women somehow working in SNYK, or at least the ones that I've interacted with. Don't know how they did that. That's very great and also amazing to see in a company. For a separate podcast another day, I think, or something like that. But anything else you'd like to add before we close up?
No, just to say thank you to everybody that did attend, and thank you, GlobalDots, for the opportunity to be here. Certainly, and always enjoyable to sit down and talk through some tech and how we can do things to make our world a little more secure. So thanks again.
Okay, awesome. Take care.